Hello and welcome to another episode of Around the Verse, our weekly look at Star Citizen's ongoing development. I'm Chris Roberts.
And I'm Aaron Roberts.
And together we're Roberts Squared.
Anyway, I'm out in LA working with Chris and the team on the upcoming 3.0 release, Squadron 42 and beyond.
Yeah, and it's nice to have you out here hosting ATV with me. We've got a lot of cool stuff planned going forward for 3.0 and beyond, and making sure the entire production team is on the same page is essential.
Yeah, absolutely. Tracking the progress of all the new features and assets we have planned is an absolutely massive task.
Yes, it definitely is. And there is a lot of technology coming online soon that we're excited about. One of those is serialized variables, which is the subject of our featurette today. And while it may sound like high school algebra, it's actually a critical system that's a core element of what we call Star Network.
But first, before all that, let's go to talk to Eric Davis right here in Los Angeles for a studio update.
Hey everyone, welcome back to Los Angeles. I'm senior producer Eric Davis, back with our monthly studio update. Since I last saw you, we've been focused on closing out final features and tasks for SC Alpha 3.0 and Squadron 42. Part of this month, I visited our Frankfurt and Wilmslow offices and worked closely with their teams for a variety of reasons. And now I'm glad to be back home to give you this update. Our narrative team has been quite jam-packed this month as well. With Item 2.0 coming online, they have been knocking out a massive amount of component descriptions needed for the 3.0 release. Everything from coolers to shield generators to quantum drives. The team has been also working on NPC voice packs for 3.0 as they wrote and recorded roughly 2,800 lines for generic NPCs to really liven up the world. Speaking of massive amounts of dialogue lines, one of the challenges in dealing with a universe of this scale is keeping track of the various characters and lines that the player will encounter. To keep track of all this, the team has created a first pass at the persistent universe character tracking sheet to provide a single resource for reference of lines, file names for departments like audio, animation, facial capture, and performance capture, and overall status and priority for the massive amounts of dialogue for NPCs, mission givers, and much more. Once this is completed, it will help us immensely as we move through the integration of new mission givers and NPCs in the future. And lastly, the team has been in the process of walking through the locations and writing up documentation of what we'd like to see as far as props, posters, signs, branding, and set dressing to really make much more immersive environmental storytelling. Also, as part of the upcoming 3.0 release, we're very excited about introducing cargo as a mechanic. And to ensure your ship is technically equipped, we've wrapped up developing the cargo grids to provide the visual element of transporting commodities like minerals, scrap, and food. The number of commodities you'll have will manifest as stacks of crates located within the ship's cargo hold, limited in capacity by the dimensions of the grid your ship can use. You'll be able to park vehicles and other loose items into the cargo hold as well, but just beware that it will limit the amount of grid space you'll have available for bought or scavenged commodities. Code is wrapped up on the feature while design has now implemented the new cargo grids into all the ships that can carry cargo. So you'll be hauling to your heart's content in no time. Engineering has also just finished up implementing the solar system content, or what we've been calling object containers, into a hierarchy to ensure that outposts on a moon or planet, as well as space stations in near orbit, are all in the correct planetary grid at all times. So for instance, Grimhex is now located inside the grid of the moon Yella for the time being. And then speaking of the all-powerful object containers, we've also just been provided the much-needed object container editing. When creating a gameplay level, we build that level with a combination of assets and object containers. Originally, object containers had to be built in a dedicated object container level, which unfortunately made the contents of the object container only editable in the actual object container level. Are you confused yet? In other words, when designers are building levels with object containers, but want to modify the contents of that object container, the only way to do that is to exit the current level, open the object container level, do some tuning, save, export, and leave, then they'd have to move back into the level. What the team has done now allows the designer to edit the contents of an object container, save and export, all while inside the level. This creates a much better experience for our design team, and it's really going to save tons of time. Now, as a general approach in game development, we always try to make something once and make it perfect. But since reality never meets expectations, we are always looking for ways to reduce the time needed in what we call the discovery phase of a problem. One of the hardest parts about getting a code bug is finding out what is causing it and where it's located. So establishing tools and processes to reduce that time not only helps get to the speedy resolution, but also gets our talented programming team back to that feature we're also excited to develop. So to that end, we've reworked the handling of vehicle internal damage states to significantly easier to set up now and debug. Interior damage states will be changed based on the cumulative health of a ship. Formerly, it was written in flowgraph, but now it has been integrated into the vehicle component so that it can be used in a variety of places. This new debug and setup process should do just that, help us find the problem quickly, solve it fast, and get back to feature dev time. Now, on IFCs, we've now moved the entire intelligent flight control system of our ship's update process to batch update. Because IFCs is very isolated from the physics engine, taking in values like velocity, mass, center of mass, etc., and outputting one linear and one angular impulse, there's no reason IFCs needs to be updated in lockstep with the physics thread. This change will be much more efficient, eliminating a major bottleneck and hopefully allowing a larger number of simultaneous players on a server. We've talked about also making progress on this for a little bit now, and we've now completed the new Quantum Drive 2.0. We've removed the old code from the previous Quantum Drive system that controlled things like VFX and sound effects playback, as well as object obstruction detection and alignment code. We've also moved the targeting of a quantum point to the target selector on a ship, so that Drive now only cares about the travel point itself. This reduces complexity of the drive code and should make it run smoother. We're doing some bug fixing as well as some features that attach to the quantum drive, such as closing all external doors when doing a jump to help prevent accidents by jumping out of a ship traveling at high fractions of the speed of light. This should all result in a smoother working quantum drive that is ready for design and art to really start tweaking and implementing on all the ships. It's also ready for UI to start creating a much more realistic feel for how such an event should be handled in-game, as well as a few other features like the star map. Now over on the LA ship front, the RSI Aurora has gone through a final art check this week. All that remains are any incoming bugs while going through design implementation, animation updating, sound effects, and VFX, etc. with this ship. And we've also established up to 14 different skins for the designers to utilize as well. The Anvil Terrapin is finalizing its gray box phase, which means it's setting up the exterior hierarchy, polishing proxies, and baked and migrated animations. For the interior, we've currently polishing the geometry in the cockpit and the habitation, and now moving into final art. We've just handed the Terrapin over to Tech Design for their gray box setup on the ship as well. Also, now that the conversion for ships to Item 2.0 is underway, it's made sense to update our ship stats page on the website. And we're really excited to finally be able to get to the up-to-the-minute stats for all of our ships, for all of you min-maxers out there. The design has now been finalized, icons finished and refined meaning, and everything's being updated on the web as we speak. They're being implemented onto the RSI website with more details to come in the very near future. Now, tech art's roles tends to increase the closer you get to a major release, and as performance begins to take priority over feature and asset development. Using a plethora of internal tools, tech art has been reviewing the release to identify code and content fixes that would dramatically improve performance. One in particular is called Statuscope, which plots graphs from data logged on a per frame basis. And more generally, it's the system that produces and manages that data. In essence, it provides a way of recording values such as FPS, number of draw calls, etc. from Star Citizen, and showing how they change over the course of a playthrough. This really helps our development team find ways to improve performance by looking for frame time offenders. Now, Tech Animation improved the animation format that animations are saved as and then reloaded into a scene. In our worst case scenario, a scene could take up to 50 minutes to load into Maya due to the amount of characters and length of the scene. But with this improvement, the worst load time has been dramatically reduced by over 82%, meaning cinematics won't be waiting long to make quick iteration. And over on the skinning front, a female transfer mesh has been created, and the male transfer mesh has been massively updated. Now, these transfer meshes are used in conjunction with all of our skinning tools to automate basic skinning of all of our new characters. Tech animators can now spend time perfecting the weighting of a mesh, allowing for a higher quality and a more accurate deformation in less time. On many of our heads, we've run into an issue where the eyelids had some vertex normal issues, which led to eyes looking pretty odd. Our tech art team has now identified the issue, and because the vertices of the eyelids were so close together, the normal would get flipped, but only on a few verts. So this has now been fixed, and characters can now sleep with ease. And speaking of characters, the team here has been knocking out countless costumes for Squadron 42 and Star Citizen. Currently in production, another female character is finishing up her in-game asset and then will be sent over to texturing and rigging, along with our OMC undersuits that have all finished up in-game modeling and they're heading on over to texturing. The team also has several other Levski-specific characters, the civilians and the miners, which are currently being textured, then will head over to rigging and implementation into their final resting place in-game on the great planet of Delamar. And now in other exciting news, now that we're in a modular armor system, we're reworking some of our legacy UEE and pirate armors to bring them up to the quality of our current assets. This will allow them to be swappable with all those assets. We've officially started high poly on some of your favorites. Then we'll be moving on to the in-game modeling and texturing pass rework. And speaking of customization, along with the new eye options, we'll have a multitude of styles of hair coming in the upcoming releases, starting with a select group for 3.0. These are in various states of production and heading toward the final finish line. We'll have a select group ready for the initial release, and we can't wait to cover up those hairless heads. And finally, we have more finished, rigged, and implement characters, starting with the male Marine BDU, which will make its appearance in several places, including the Bridge of the Idris. The male deck crew can now safely EVA outside the ship in the vacuum of space when doing his work. And lastly, the female light armor has finished up her implementation pass, along with the female Explorer flight suit, which will support her in the far reaches of the galaxy. Well, that's about it and wraps us up here in Los Angeles. As always, thank you for allowing us to create this game we've always dreamed about, and we look forward to giving you more updates in the near future. Have a fantastic rest of the week, and we'll see you back in Los Angeles in no time.
So it'll be nice to see people hauling something other than Big Benny's vending machines and unsuspecting NPCs. As great as all those videos were, the team has worked hard to give you a proper mechanic for the 3.0 release.
Yeah, I mean, cargo is just one of the many important features we're currently working on. A lot of them, like cargo and, say, derelict ships, will be easy to see, while others, like serialized variables, aren't as visible but are just as critical to the game.
Yeah, no, they're absolutely definitely as critical to the game. Because when you're attempting to build a game as large and complex as Star Citizen, it's essential to come up with a new way to streamline the data being transferred between the server and the clients.
And so here to explain exactly how serialized variables will improve our networking capabilities and, of course, most importantly, your Star Citizen experience, let's hear from lead network programmer Clive Johnson.
My name's Clive Johnson. I work for Foundry 42 UK, where I'm the lead network programmer working on Star Citizen. Today we're going to talk a little bit about serialized variables. So what are serialized variables? Well, they're not really something that you can see in the game, and ideally, if everything's working the way it should, then they're not something that you really ever need to think about. But they are the answer to a question, which I think is quite important, and that's how do you network a game like Star Citizen? One of the first times I asked myself that question was shortly after I joined the company. I think my first reaction was one of sheer terror. Tears, panic, and once it kind of calmed down and the tears had stopped, you do what any engineer is going to do when faced with an impossible problem. You try and break it down into smaller, impossible problems. When trying to answer the question, how we network Star Citizen, one of the first things we've got to think about is exactly who's going to do the work, who's going to network everything we have in the game. Now, Star Citizen itself is made up of thousands of different elements, and some of these are visible, like planets and ships and players and coffee cups, and others you don't see, like missions or the logic assigning out landing pads. Each of these elements is really a different type of entity. and each type might be used thousands of times throughout the game. But all the types behave in specific ways or have certain uses, and that has to be implemented in the code. And most of them need to work in both single player for Squadron 42 and multiplayer for Star Citizen. In other words, most of them have to be networked. So who's going to do the work? Well, currently we've got about 60 engineers coding different parts of the game, but we have only 6 network programmers. Half of these work in Austin on back-end services, and that includes, our core online services such as matchmaking and friends and player authentication. The other half is my team here in the UK, and we focus mainly on the networking between the client and the server. So it's kind of up to us to make sure that all the entity types are correctly networked and everything's functioning the way we'd like it to in the multiplayer game. But with 60 programmers or thereabouts writing new code and making new entity types, if we've only got 3 actually making it work in multiplayer, my team needs to work about 20 times faster than anybody else. We're good, but we're not that good, so clearly leaving all the networking to the network programmers is not going to work. So what we need to do is have every engineer make sure that their own code works in multiplayer. But the problem with that is that network programming is really very hard, and it can take years to learn all the different ins and outs. So we need a way to simplify it so that non-specialists can learn everything they need to do in just like a couple of hours. What we need is an API, which stands for an application programmer interface, and that's really a cushion between a programmer doing the work and the problem that they want to solve. The API kind of simplifies things by allowing the programmer to say exactly what it is that they want to do, but without saying how it should be done. So you can kind of think of it like driving a car. So obviously you've got your steering wheel and the pedals and other controls, gear stick, whatever. That's not how the car drives. They're just the controls that tell the car what to do. So under the hood, the driver's commands are turned into different settings for like fuel air mixture or engine timing or hydraulic pressures for brakes and power steering. And that's kind of the interface part of an application programmer interface. By building the right set of controls, you can change how the API actually works without having to change the code. So what about driver error? Cars equipped with assisted driving can take action when a driver makes a mistake and possibly prevent a crash. And we want the same sort of thing from the API that we're going to develop. When a programmer's using it, it actively prevents them from making mistakes that might cause us bugs or negatively impact performance. But we can go a bit further though. So currently the technology for driverless cars is being developed. When that happens, the skill needed to operate a driverless car drops to just saying where you want it to go. And this is what we've tried to do with our network API. Serialized variables are a really big part of that. By giving our programmers a simpler model to work with, they can quickly and safely network the game elements that they're working on. Meanwhile, as network programmers are freed up to try and ensure that the API not only works quickly and efficiently, but also it deals with all the problems that you can get while networking anything. So before we go any further, we probably need to talk about another question, and that's how do online multiplayer games actually work? If you were to see the game as programmers often look at it, you'd see that everything is essentially lots of tables of values. Every entity in the game has its own table, and each value corresponds to a different property of the entity. Because we need to know what each value's for, we've got to give them all names. So a table has 2 columns, names on the left-hand side and values on the right. A row in a table is what we call a variable, and that's mainly because its value can change over time. A ship might have variables for shield strength and how much fuel it's got left. Players can have variables to say whether they're running or walking. And most, but not all of these variables will have an entity called a position, and that's going to tell us exactly where they are in the game's universe. And even though we kind of need 3 values for coordinates in 3D space, we tend to think of position as a single variable because one part changes, the other parts tend to change. So when an entity moves, it does so because the position variable has been changed, that variable is not really just keeping track of where the entity is, it's actually saying where the entity is. Programmers can write code that looks at the values in a table that belongs to an entity, and we can use those values to calculate some changes to other variables, and some of those variables might be in the same table, or some might be in other tables belonging to different entities. So as the game progresses, these variables are modified according to the actions of players and AI, and these changes update the graphics that you see on screen, and they can trigger particle effects and sound effects. To make this work in multiplayer, we've got to take one machine, the server, and have that make the changes to the tables, and then the server then needs to copy the modified tables to all the other machines, all the clients, and it does this by sending messages over the network, a bit like a group text message. And if everything works correctly, the clients and the server all have the same data in the tables, and everyone's in sync. Now, entities in our game can have dozens or even hundreds of these variables or properties, and most of them need to be kept in sync over the network. There are a few ways we could do this, and probably the most straightforward way is every now and then just to send the state of all the tables. And that works really well for very small numbers of entities. But as the number of entities increases, then the bandwidth that you're using to do that increases, and if we're not careful, that can cause us other problems. We might notice that most entities in the game don't tend to do much until someone does something to them. So what we can try is not sending the table for an entity unless it has changed. But now, the game code's got to keep track of which entities have changed and which haven't, and that can be tricky to get right. It's a manual process that the gameplay programs have to do. Getting it wrong means that in certain situations, the tables for particular entities will no longer be in sync. We call that a desync, and the effects of that can range from like minor bugs that are just little annoyances to completely breaking the game. And the only way to find these bugs is through lots and lots of time-consuming playtesting. Perhaps worse, we haven't really solved the bandwidth problem either. By adding more players, that means that more entities will be being interacted with and having things done to them. So more tables are going to be getting updated, and more messages need to be sent out over the network, and the bandwidth jumps up once again. We still need to reduce this. So we might notice that when an entity's table is modified, not all the values in it are changed. So instead of sending the whole table, we could try just sending a few of them at a time, so we can split the table into sections. And then we're saving bandwidth by only sending a section if one or more of the variables in it have changed. If we put variables that are likely to change together in the same section, then we can save even more. But now the game code's got to keep track of not just modifications to entities, but modifications to individual sections. And that's even harder to get right. We've also got to write some extra code to say which variables need to be put into which messages. And since different types of entities have different sets of variables, they also need different sections. So this extra work has to be duplicated for every different type of entity. So the thing that really kills this plan for Star Citizen is entity components. A component is really, it's just a piece of code and some variables that implement a very specific piece of functionality. So entities get built by plugging different components together, and by choosing different components that you want to plug together, that gives us different types of entities. If you need an entity that can move around and collide with other things, then you have to give it a physics component. Your entity needs shields, give it a shield component. The number of different entity types we can build this way grows exponentially with the number of different components that we have, but what also grows exponentially is the amount of networking work we've got to do to cover all these different entity types. So clearly this isn't really going to work for us. Our networking API needs to be smarter. What we wanted were controls that were as simple as those for a driverless car, and what we had felt like it was as complicated as piloting a space shuttle. So that's when we came up with serialized variables. So with these, gameplay programmers just need to write their code the way they normally would. They're adding variables to their components as they need them, and the only extra thing that they need to do is mark the variables that they want networked in a special way. And that just shows that these ones are ones that need to be serialized. Serialization is the process of packing up the data in a form that's more efficient and better suits being sent over the network or serialized to a file.
This makes life so much easier for our programmers. You can see how the code on the left can be simplified and reduced to what's on the right. It's really just like writing normal code and calling out which of the variables we want serialized. The program only needs to write the additional lines that you can see highlighted in purple on the right and add them to their struct or class definition. And that tells the serialized variable system which members of the structure to watch and update. Previously, we would have needed specific functions in each class, one for net serialized for networking, full serialized for the save game. And if we wanted to talk to the persistent database, we would have needed an extra function, something like persistent serialized. In these functions, the game programmers would have had to manually look at the variables they wanted to serialize and write them out into the serialization stream. So there's lots of scope there for extra work and possible errors if they forget to add a variable. But now, when a programmer writes a new class, they can just mark up which of the variables they want to be serialized, and everything else is handled automatically and efficiently behind the scenes. And that all goes through one unified system that we can profile and optimize, as opposed to having to worry about optimizing literally thousands of different functions. Once the variables have been marked, there's no need to group things into sections anymore. There's no extra code to write. The API detects when something has modified the value of a variable, and it lets the netcode know so that that can deal with it. New API even writes the code to handle the serialization for them. And this kind of level of automation, it not only saves us time, but it eliminates human error, meaning we have a lot fewer bugs, and we can just get on more quickly and more efficiently. So because the netcode's now being told about changes to individual variables, we on the networking side have a much clearer view of what's actually happening in the game. So you can kind of think of it like switching to a 4K TV when all you've ever seen before was like grainy black and white. And we're kind of using this extra information at the moment so that we only send exactly what has changed. And that means that our bandwidth per update message, the size of our update messages is now probably about as optimized as it's possible to get. We're also using this information so that we can profile what's being sent by the game code, when it's marking variables dirty, so we can see if anyone's hitting anything particularly quickly and maybe there's a bug in the game code that needs looking at. Really, the only kind of other improvements that we're going to get from now on are by optimizing like streams of network messages, cutting out who's sending messages at all and how often messages are being sent. We can handle all that on the network side, on the netcode side. So it's kind of like I was saying before, where we've got this interface with the API that separates game code from what we need to do, and we can make our changes without affecting that. While we were working on this new technology, we noticed that one of the entity types started sending about 80% less data. And at first we just didn't believe that. We were certain that the numbers have got to be wrong, or that a bug's throwing away most of the data. It wasn't until we went back and we double checked everything that really we started to realize that this saving's actually real and that it's due to the new code. That's probably not going to be typical, but it still kind of shows that the difference this kind of approach can make. That's not entirely where the story ends though, because one of the other cool things about serialized variables is that they don't just work for multiplayer and networking. Instead of sending the different tables and values and variables between just server and clients, we can also store them in a database or save them to a file. And that means that for no extra effort at all, the gameplay programmers can use the same serialized variables for persistence, recording what the state of entities is in our persistent universe. And we can even use them for save games in Squadron 42. Personally, I think probably the best thing about serialized variables is that they're one of the cornerstones that we're using to build this big, seamless, persistent universe. Achieving that is going to require spreading the load over multiple servers. Because it's seamless, we're going to have these servers communicate with each other, and that's going to mean that there could be a lot of servers aware of any particular entity. So let's say, for example, an AI pirate. Now, we don't want all the servers trying to tell the pirate what he should be doing, because first, that would be just a complete waste of computing power. And the second reason is that the servers might not agree on what the AI should do next. So we need one server that's in charge of the AI pirate, and only that server can send updates for that AI pirate entity, and the other servers just listen to it. So the trick is going to be how we decide which server gets the final say. And we're going to do that with something that we're calling tokens. A token can only be held by one computer at a time. And when a computer's finished with a token, it just passes it on to the next one that wants it. So by linking serialized variables and tokens together, we'll be able to transfer authority from one server to another as quickly as flicking a switch. What that means for our AI pirate is that control over its AI mind can pass
seamlessly from one server to another. And since different servers, at least initially, will control different regions of space, this combination of tokens and serialized variables will allow our AI pirate and everything else to move freely through this seamless, persistent universe that's being simulated by lots of servers all working together. So hopefully you'll agree that serialized variables are not only a key part of the current technology, but they're a building block for future ones. And that's really not bad for something that you're never going to see. But that's often the reality of game development. And what you see in games is really just the tip of an iceberg that's being buoyed up by a mass of systems and technologies all working together, out of sight and fingers crossed out of mind.
So as you can see, the serialized variable tech is an important feature for several reasons. It not only improves the game's networking, but also simplifies the coding for our programmers, so there'll be fewer bugs going forward. And the same data can be serialized over the network to the persistent database or save the state of the game, meaning we have one unified way to communicate or save game state throughout everything, which is very important for a big, huge universe like we're building.
Absolutely. Anyway, that's it for today's program. But before we go, we wanted to remind all backers to keep your account safe by enabling two-step authentication. You can do that by visiting your account page, then clicking on the Security tab under Settings.
Yeah, it's probably a good idea to do that. And thanks to all our subscribers. Your continued support makes ATV, Bug Smashers, and all our programs possible.
And don't forget to tune in tomorrow for another one of our subscriber-supported shows, Happy Hour Friday. This week, Ben Lesnick will be playing Wing Commander 3 and discussing the history behind the game and its development. And in mine and Chris's case, that's a long time ago.
Yeah. I think 24 years ago we were developing it. Anyway, time flies. Finally, I'd like to thank all our backers. Your support and enthusiasm for the game has made all this possible. We couldn't do it without you.
So until next week, we'll see you
around the verse. Thank you for watching. So if you want to keep up with the latest and greatest in Star Citizen and Squadron 42's development, please follow us on our social media channels. See you soon.